Um, can you can you see my screen? Okay, so today we're going to discuss the chapter 2, 3, and 4 for the tutorial. So this document has already been shared last 2 weeks. So it should be on the WhatsApp. All right. So you could open it. All right. So we look at problem. So we have problem 2.3. Okay. 2.6, 2.17, 2.22, and until 2.89. All right. Okay. So today I'm going to just pick up some of the problems, and then you need to solve the rest of the problems. Okay, and then but for the rest of the problems I will give you the answer so you can whether you get it correct or not. Okay, so for example we look at the problem 2.3. First is the problem said you normally drive on the freeway between San Diego and Los Angeles at an average speed of 105 kilometer per hour, and the trip takes 2 hours and 20 minutes. Okay, on a Friday afternoon, however, heavy traffic slows you down and you drive the same distance at an average speed of only 70 kilometer per hour. Okay, so how much longer does the trip take? Okay, so how to solve this problem? All right, so basically, so you already have 105 kilometer per hour and the trip takes 20 minutes. Okay, so meaning that, all right, so you need to find out what is the distance between San Diego and Los Angeles. Okay, so once you found that, then you can use the distance to calculate the time taken, all right, by dividing with the speed. All right, so you will get the time. All right, so let's say okay, so this is not the correct one, so I just said okay, the distance is 700 kilometer. All right, so the time taken, right, time taken is 10 hour destination, because you are driving at 70 kilometer per hour. All right, so 700 divided with 70, you obtain 10. So basically you are traveling at your travel time is 10 hour. Okay. Hmm. Okay. All right. So for this one, all right. Okay. So for this one, the time taken is 3 hours and 30 minutes. So the answer should be 1 hour and 10 minutes. Okay, please write down the answer. Okay, so all right. So for 2.6, I will just give you. Okay, so for A, it should be 2.8 meters per second. All right, and B, okay, and B is 5.2 meter, and C, it is 7.6 meter per second. All right. Okay, we will look on the problem 2.9. Okay, for the problem 2.9, let's say a ball moves in a straight line, the x-axis, okay, and then the graph in figure E2.9 shows this ball's velocity as a function of time. Okay, and then for A, what are the ball's average speed and the average velocity during the first 3 seconds? Okay, so what is the ball average speed and average velocity during the first 3 seconds? So we have the velocity, it's 2 meter per second for the first 2 seconds and 3 meter per second for the last second. Okay, so over here, for the first 2 seconds, so the delta t, right? So the delta t is 2 seconds. So the speed at those delta t is 2 meter per second. So we obtain, right? We obtain the delta x. Okay, we obtain the delta x as 2 meter per second times 2 seconds. So we get 4 meter. Okay. So for t from 2 to 3 seconds, so we have the delta t as 1 second. And then the delta x is, okay, the speed over there is 3 meter per second. So 3 times 1, so we get 3 meter. Okay. All right. So for the first 3 seconds, the distance travel is, okay, previously you obtained 4 meter. All right. And then you also got another 3 meters. So the distance travel is 7 meter. Okay. And then the average velocity, okay, so the average velocity, so VAVX is equals to delta x divided with the delta t, okay, which is 7 divided with time taken is 3. So the average velocity is 2.33 meter per second. Okay. So I hope you get it. All right. So for B, suppose that the ball moved in such a way that the graph segment after 2 seconds was minus 3 meter per second, okay, instead of 3 meter per second. Okay. So meaning that it is inverse in terms of the direction. So the ball is moving to the other side. Okay, so how to solve this? So we need to find out the ball's average velocity. in this case. Okay, so what do we have here? So the information said that what the so what's -3 meter? Okay. Alright, so um for 2 to 3 seconds, it said that the velocity, all right, the velocity over there is -3 meters second. All right, so the delta x over here will be -3 times 1, so it will be -3 meter. And then, so the total of delta x, I mean the distance traveled, so it will be less. Okay, for the first one, for the first 2 seconds, it is 4 meter, as you remember. And then we need now to minus 3 meter. So now the delta x is 1 meter. Okay. But as you know that the distance traveled is still 7 meter. Okay. But now you want to find the average speed. So the average speed is depend on the delta x. So the delta x is 1 and then divide with t. So the average velocity will be 1 divided with 3. Okay. So you 0.33 meter per second. Alright. And then the average speed will be, so what's the average speed? So the average speed will still take the total distance traveled, which is 7 meter divided with 3 seconds. The answer for the average speed is 2.33 meter per second. So that's the difference between average velocity and the average speed. For the average velocity, so the velocity considers the reverse in the direction. But for the speed, you will just sum up all of the total distance traveled. Okay. All right. So that's the answers for problem 2.9. Okay, so for 2.17, I will just give you the answer. Okay, so for 2.17, so we need to calculate the average acceleration for the time interval t 0 second to t 5 second. Okay, so the first one, the average acceleration will be 0.5 meter per second squared. Okay, and then for B, we will have the instantaneous acceleration. So the instantaneous acceleration will be okay, so it will be 1 per second squared. Okay, at t 5 second, all right, and at t 0 second, it will be 0. Okay, so that's the answers for B. And C, need to draw. Okay, so you need to draw that. So the graph will be a linear graph. Okay, so the point, okay, so the point, the The point on the graph will be at time 5 seconds. So you have the acceleration of 1. And then at time 0, so you have the acceleration also 0. So you just plot the linear graph. Okay, so that's for C. Okay, so all right, so you have two. Okay, so for 2.22, I will also give you the answer. So for the 2.22, we have A. Okay, so the ball acceleration during the serve. So we have the acceleration as 2440 per second squared. Okay, and then for B, how far did the ball travel during the serve? So we have 1.1 meter. Okay, so that's for 2.22. Okay, all right, so 2.29. I will also give you the answer. So we will have A. So for A, it is what is the average acceleration in meter per second squared of the shuttle. Okay, so you already given that information. So you need to find what is the average acceleration. ABX. So you have that. Okay, so number during the first 8 seconds. So the first 8 seconds, it will be 5.59 meter per second squared. So that's the answer. And then for 2, between 8 seconds and the end of the first 1 minute. Okay, so the answer will be 7.74 meter per second squared. Okay, and then for B, assuming that the acceleration is constant during each time interval. Okay, so what distance does the shuttle travel? First, during the first 8 seconds. Okay, and second, from 8 to 1 minute. From 8 seconds to 1 minute. So for number 1, the answer is 179. Okay, the answer is 179 meter. And then for number 2, the answer will be 1,280 meter. So the answer will be 12,800 meter. Okay, 12800. Okay, or equivalently 1.28 times 10 to the power of 4. Okay, so that's the answer for 2.29. All right, so we will discuss the problem of 2.47. Okay, so for the from 2.47, we have the 15-kilogram rock is dropped from rest on the earth and reaches the in 1.75 second. When it is dropped from the same height on Saturn's satellite Enceladus, okay, it reaches the ground in 18.6 seconds. So you can see that the difference of the time for the rock to drop in Saturn, okay, okay. What is the acceleration due to gravity on Enceladus? Okay, so the acceleration due to gravity of the accelerators mention that as G En. Okay, so the gravity of the accelerators, and then we mention G. Okay, we mention G as the acceleration due to the gravity on Earth. Okay, and then so we assume that the height, okay, the height as H be the common height from which the object is dropped. Okay, and then so we have the y-axis. So the plus y, okay, the plus y will be downward. So y, okay, so currently y, so y, which the current location, okay, so which is the current location minus with the initial location y naught is equals to the height. Okay, so meaning that the y is the location at which the ball is already dropped. Okay, y naught is the initial position of the the ball. Okay, oh sorry, of the ball it is dropped. Okay, and then we have the v naught y, okay, the initial velocity as 0. Okay, so how to solve that? So we have remember that the uh, equation for the acceleration. So we have y minus y naught equals to v naught y, okay, times t plus half ay t squared. Okay, so one. Okay, so basically, right, so we have that equation as y minus y naught, okay, equals v naught y times t half a y t squared. Okay, so this is the equation that we use. All right. Okay, so basically this is h. Okay, so that's the height. All right. So this one is 0. So this term can be crossed. So what we have is h equals to half a y t squared. All right. So what is the ay? Okay. So of course the ay will be the um, gravitational force. All right. so the gravitational force, so we have two situations here. As I said, the GEN for the uh, gravitational force or acceleration due to the enceladus, okay, and the other one, the gravitational force or the acceleration due to the gravity on Earth. Okay, so we replace this. Okay, so we replace that. So what we have now is H. Okay, so H equals to, so we have, okay, let's say for this is for the gravity of the Earth, and T what? So that's the gravity of the Earth. And then we have the one H. Alright, so we have the gravity of the acceleration due to gravity of the enceladus, so En, and then also E for the enceladus. Okay, right. So okay, now you already get the two equations. All right, one for the enceladus and the other one for the Earth. Okay, so the question asks about the acceleration due to gravity on the enceladus. Okay, so mean that you need to find this one. Okay, find this one. All right, so because you already obtained it, so it should be easy. All right, so basically, so this H, okay, H, and also H is equal. So what we have, so of course, when this is equal, this also will be equal. So what you obtain, so half G E T E squared equals to half G E N T E N squared. Okay. So your task is to find this one, right? So because these are similar, so you can cross half, oh sorry, you can also cross half, okay? So what is left? So you rearrange back this equation, okay? So you arrange back that equation. So what you get is okay, so what you get is, all right, so GEN equals to, okay, GE TE squared divided with TEN squared. Okay, so you should get the answer, all right? So you just plug in that value, those value, and also that value. So you should get the answer. So what is the gravitation, the acceleration due to gravity of the Earth? Of course, it is 9.8 meter per second squared. And then for the TE, so 1.75, okay, squared that, and then divide with 18.6, and you squared that. So your answer will be 0.0868 meter per second squared. Okay, so that's the answer. All right, so let's move further. Okay. All right, so we already solved 2.47. Okay, so all right, for 2.89, I will give you the answer. So for A, what it asks, so it asks about what is the maximum height, okay, above ground reached by the helicopter. The maximum height is 378 meters. Okay, so that's the answer. And then for B, we have the power deploys a jetpack strap on his back 7 seconds after leaving the helicopter. Then he has a constant downward acceleration magnitude of 2 meters per second squared. How far is powers above the ground? Okay. So powers is the name of people, okay? So how far is powers above the ground when the helicopter crashes the ground? Okay, so you need to find out how far powers above the ground. Okay. So the answer is power is 184 meter. 184 meter above the ground when the helicopter crashes. Okay, so that's the answer. All right. We move to chapter 3. Okay. Motion into all 3 dimensions. Okay. So, all right. We will discuss 3.9. Okay. Let's say a physics book slides off a horizontal tabletop with a speed of 1.1 meter per second. Okay. It strikes the floor in 3.35 seconds. Ignore the air resistance. Okay, we need to find the height of tabletop above the floor. Okay, so that's for A. Okay, and then B is the horizontal distance from the edge of the table to the point where the book strikes the floor. Okay, so the problem basically is like this. Okay, so the problem is basically we have the book. Okay, it's at the edge of the table. Okay, and then this is the ground. So let's say that's the table there. So it slides off. Okay. It's a projectile motion, half of the projectile motion, and then the book drops. Okay. All right. So you have the information given that the speed, okay, speed is initial speed, so it will be v naught, so 1.1 meter per second. Okay. So we need to find out, so the time taken, the time travel. So it travels, okay, the time travel. So the t is equals to 0.35 second. Okay, so that's the information that you have. All right. So at this moment, okay, at this moment, of course, the acceleration will be 0. Okay, so you need to find what is the height of tabletop above. You need to find this height. So what is that? All right. So you also have the y component, right? So you have x and y component. So for the y component, the acceleration, okay, ay, of course, it will be due to the gravity. So it will be because it's going down, so it is minus 9.8. Okay, minus 9.8 meter per second squared. All right. And then for V naught Y, so this is V naught X. So this split. Okay, and then V naught Y. So that, so V naught Y will be equals to 0. All right. So the time taken is 0.35. All right. So given all of this information, so you need to solve to find the height. Find what is the height. To find out what is the height, so you use the similar equation like before. So we have y minus okay, so y minus y naught equals to v naught y t plus half a y t squared. So this is actually your height. Okay, as you remember, this is actually the height. Okay, so we already have this. Time we also have. Okay, and then ay we also have. Okay, so ay is minus 9.8. V naught y is 0. Okay, so we left with this equation. Okay, we left with that equation. So basically it will be equal, so the height will be equals to half minus 9.8. Okay, and then t, okay, so t is 0.35 squared. So the answer is minus 0.6. So the height of the table, height of table is 0.6 meter. Okay, so that's the answer for A. All right, so how about B? Okay, the B asking you about the horizontal distance from the edge of the table to the point where the boat strikes the floor. So we find the height, we already found the height, and then need to now find the distance. Okay, distance where the book, okay, where the book drops, the horizontal distance. So it is this one. So you have that. Okay, you have the book, you have the table. All right. So the book drops there. So you need to find this. Okay. So we just reverse that equation. So now we take the x. Okay. So it is x minus x naught. Okay. Equals to v naught x t. Okay. Plus half a x t squared. You already have that equation, right? So this is what you need to find. Okay. So t you already have. Okay. Ax. So this term is 0 because ax to that direction is 0. Okay, because it just have the ay component. Okay, minus 9.8. So system now is 0. So you have that, which is equals to, so v naught x. So you already have that v naught x as 1.1. Okay. So that's 1.1 times 0.35 the time. Okay, so what's the answer? So the answer will be 0.385 meter. Okay, so the answer is 0.385 meter. Okay, now we look at C. So for C, we have the C given as the horizontal and vertical components of velocity, okay, and the magnitude and direction of its velocity just before the book reaches the floor. Okay, just before the book reaches the floor. Okay, so now we need to find the velocity. So the velocity will be Vx, okay, or Vy. So Vx and Vy, this is what we need to find. So we have Vx and Vy, right? So previously, so what is that? So the equation of Vx and Vy is this one. So we have the Vx, okay, Vx equals to V naught x plus Ax t. Alright, so this is what you have. Okay, for x, and similarly for y, Vy equals to V naught y plus Ayt. Okay, so you already have all of this information, right? So you already have. So for V, well, so you have this value, you have this, but this will be 0, and then this is 0, and then you have this value. All right, so to solve that, so you obtain Vx is equals to 1.1 meter per second, and Vy is equals to minus 3.43 meter per second. Okay, so that's the answers for 3.9. Okay, so we
Sorry, Doctor. What's the answer for Vx again?
Vx is 1.1 meter per second. 1.1
Oh
meter.
no.
Okay. 1.1 meter per second. Okay, and then Vy is minus 3.43 meter per second. Okay, so this is for Vx 1.1 meter per second and Vy minus 3.43 meter per second. Okay. Okay, so let's move to 0.12. Okay, so we have 3.12. So I'm going to give you the all right. So for 3.12, so what we have here, so A is asking about how much time is required for the ball, for the football to reach the highest point of the trajectory. Okay. So for A, so the time will be 1.224 second. Okay, 1.224 second. So if you can, if you round that number, it will be 1.22 second. Okay, and for B, the height of the point. So the height of the point is 7.35 meter. 7.35 meter, right? And then C, how much time is required for the football to return to its original level. Okay, the time is 2.45 second. 2.45 second. Okay, and D, how far has the football traveled horizontally during that time? So he asks you about the distance. Okay, this distance of the ball travel. So it is 49 meter. 49 meter. Okay, so that's it for 3.12. All right, so okay, I'm going to give you the answer also for 3.26. Okay, 26. So for the 3.26, we have, all right, so we have A. Okay, so for A, what is the linear speed of the blade tip? Okay, what is the linear speed of the blade tip in meter per second? So we have the speed, the linear speed as 196 meter per second. Okay, so that's for A. And then what is the radial acceleration of the blade tip expressed as multiple of the acceleration of gravity G? So the radial acceleration, okay, so the radial acceleration, the formula is V squared over R. Okay, so radius, so that R is the radius. Okay, so V squared over R, so you should obtain, okay, you should obtain as 1.13 times 10 to the power 4 meter per second squared. But then you need to express that as multiple of the acceleration of gravity G. Okay, So you need to divide that. Okay, so you need to divide that with G. Okay, so you need to divide that with G. You get 1.15 times to 1.15 times 10 to the power 3. Okay, 1.15 times 10 to the power 3 G. Okay, so G is the acceleration of gravity. So meaning that it's like 1.15 times 10 to the 3 times 9.8. Okay, so equivalently, you will also obtain back 1.13 times 10 to the 4. Alright, so the final answer will be 1.15 times 10 to the 3 G. Okay, so the answer for 3.26. Okay, alright, so I'm going to give you the answer for 3.8 as well. Sorry, 3.28 as well. So for 3.28, so we have A. So A is the magnitude of the orbital velocity of the Earth. Okay, the magnitude of the orbital velocity of the Earth. So we have that as 2. Okay, so it's velocity in meter per second. So 2.98 times 10 to the 4. 2.98 times 10 to the power of 4 meter per second. Okay, so that's for A. And then for B, we have, okay, also the radial acceleration. Okay, so the A rad, so the A rad, the radial acceleration is equals to 5.91 times 10 to minus 3. Okay, 5.91 times 10 to the power of minus 3 meter per second squared. Okay, so that's for the A rad, the radial acceleration. Okay, so for C, we need to repeat part A and B, okay, with Mercury, okay, the planet of Mercury. So we have the orbital radius of 5.79 times 10 to 7 kilometer, and the orbital period we have 88 days. Okay, so C, for CV, okay, V this with is the magnitude of the orbital velocity. So it should be 4.79 times 10 to the power 4, right? 4.79, 4.79, right? Times 10 to the power of 4 meter per second. And the A rad equals to 3.96 times 10 to minus 3. Sorry, 10 to minus 2. So I repeat again, it is 3.96 times 10 to minus 2 meter per second squared. Okay, so that's for the A rad. Okay. Okay, look here. All right, so we have a 3.32. So for 3.32, okay, let's discuss 3.32. So a railroad flat car is traveling to the right at a speed of 13 meter per second relative to an observer, okay, standing on the ground. Okay, so this is about the relative velocity. Okay, someone is riding a motor scooter on the flat car. Okay, so the flat car is, and So the motor scooter is moving. Okay, what is the velocity in terms of magnitude and direction of the motor scooter relative to the flat car if its velocity relative to the observer on the ground is A, 80 meter per second to the right, and B, 30 meter, 3 meter per second to the left. Okay, and C is 0. Okay, so we have three different okay, so for three different situations where the relative velocity at different value. Okay, so first we need to define what is the equation for our problem. Okay, so as we learned yesterday, okay, so we learned about the relative velocity. So mention that let's right. Okay, so we have a VSF. So we have V. Okay, we have VSF, which is the velocity of the scooter relative to the flat car. Okay, so this is the velocity of the scooter relative to the flat car. All right, and then we have VSG. VSG. Okay, that is the velocity of the scooter relative to the ground. Okay, so to the people, okay, seeing that the scooter. All right, and then we have another one. So VSF, VSG. So what's another one? So that's VFG. Okay, so VFG is the velocity of the flat car relative to the ground. Okay, so we already have those three velocity. Okay, so we have the people here. Okay, so that's the flat car, right? And then we have the scooter. Okay, scooter with the people moving there. So moving. So we have here is the scooter, and here is the ground, and here is the flat car. Okay, so we have those three. Okay, so we look back here. The relationship between that is, so we have that the VSG, okay, velocity of the scooter relative to the ground, okay, is equals to, so this one, V S G equals to V S F plus V F G, as we solved yesterday. Okay, so this is equivalent. All right, so F F. Okay, so we have V S G. Okay, V S G. All right. So, all right. So what we need to find is the velocity of the scooter. Okay, velocity of the scooter relative to the flat car. So we need to find out what is our VSF. Okay, what is the question is asking about what is, so VSF is VSG minus this one, right? Okay. First, the problem give, okay, VFG, okay, VFG. So we rewrite that again. So we need to find out what is our VSF equals to VSG minus VFG. Okay. So what we were given, so it is velocity relative to the observer on the ground. Okay. So the flat car to the observer. So we already given what is our VFG. Okay. So we are given with this. Okay. So we are given with this value. Okay. All right. So we need to solve that. What is our VSF? Okay. So we have, okay, so the first information that we have, the flat car is traveling at the 30 meter per second relative to an observer. Okay, so we have that information, and then we have the scooter. Okay, scooter to the observer. Okay, scooter to observer is given like A. Scooter to the observer, so this one. So we have this one as 18. Okay, this one as 18. Right, and this one is, of course, the first one, railroad to the flat car, is 13 meter. Okay, is 13 meter. Okay, so because that's value to the right, so to the right, okay, so it is okay. So we have 18 minus 313. So we have number one, A is 5 meter to the right. Okay, 5 meter per second to the right. Okay, and then for B, we have, so we change. Okay, this is, okay, this is minus 3. Why minus 3? Here, 3 meter per second to the left. So it should be minus 3. VSD minus 3. So minus 3 minus 13. So we have minus 16. So it is 16 meter per second to the left. So that's the answer for B. And if it is 0, so if this is 0 for C, so if this 0, so 0 minus 13. So this is for C, 0 minus 13. So you obtain 13 meter per second to the left. All right. So that's the answer for A, B, and C. Okay, so let's move further. So for 3.38 and 3.9, I'm going to give you the answer. All right. So for 3.38, the answer is for A, if the airspeed of the plane is 320 kilometer per hour, in which direction should the pilot head? Okay, in which direction? So the direction will be at the theta 14 degree. Theta 14 degree, which is north of west. Okay, north of west. Okay, so 14 degree, so north of west. So 14 degree north of west. All right. So okay, so basically it's north of west. So the west is like that. Okay, so you have, so your theta, okay, your theta, you need to draw that. Okay, so your theta will be from that side. Okay, so you have, that answer is theta is 14 degree and north of the west. Okay, so that's for A. And for what is the speed of the plane above the ground? The speed is 310 kilometer per hour. Okay, so you need to illustrate the vector diagram. So you just need to illustrate what is the vector diagram. Okay, so for the vector diagram, you should have what is your VAG, VPA, and VPG. Okay, so similar like the one that we discussed in the problem 3.32. Okay, all right, so we have 3.49. So for the 3.49, we need to estimate the maximum speed at which debris was blown outward explosion. Okay, the maximum speed, okay, so the maximum speed will be 22 meter per second. Okay, the maximum speed will be 22 meter per second. Okay, so describe any assumptions that you make. So we assume that the debris is exploded to all angles. Okay, so to all angles. And at which the angle 45 degree gives the maximum range. Okay, so that's for 3.49. Okay. All right. So Okay, so for chapter 4, we haven't finished yet. All right, so that's it for chapter 2 and 3. Okay, because we haven't discussed the problem on how to solve for the chapter 4. So for this one, will be carried out to the next tutorial. Okay. Right, so your task is to finish with chapter 2 and 3 and then submit that to the Putra Plus. Okay, so your submission will be due by next Monday, right? So it will be due by next Monday. Okay, so that's it for today. For the lab submission, I will extend it on the Putra Plus so you can submit it by Friday. So 11:59 p.m. by Friday, you need to submit that. And then there is some concern about the question for the experiment 2. So where you have the y equals to the square root of something x plus 2q, square root of ax plus 2q. So I'm going to make it a little bit easier for that question. Okay, so you just remove the square root. So now you have the equation of y equals to ax plus 2q. Okay, I will share you the latest lab manual on the WhatsApp group, and then you can just use that equation to make the new plot. Okay, and obtaining the answers for the question. Okay, what is A and what is Q? Okay, so any question?
Doctor,
Yes.
can we submit the lab report?
Yes, you can submit the lab report already.
Oh,
But I need to change the question. But if you have done with the square root, it is okay. But actually, it is a little bit difficult. I'm not sure whether your answer is correct. I'm going to make it easy by removing that square root. So you have that the new equation as y equals to ax plus 2q. So you have a linear equation, right? So I will update that lab report, the lab manual to the WhatsApp, the new with improvement on that part. So you can just make a new plot and then find out what is your A and then what is your Q, and then the error within that uh, linear. Okay. All right. So I'm going to give you a new one after this class. All right. So lastly, so let's take a picture together for the attendance for today. So could you please turn on your camera? Okay, so please be ready, everyone. Okay, so I'm going to count from 10. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and cheers. Okay, one more shot. Uh, one more shot. Okay, thank you, everyone. Okay, so I see you again on Thursday. Okay, so that's it for today. Okay, so bye-bye. All right, and Assalamualaikum.
thank you, Doctor.
Okay, welcome.
Thank you,
Thank you,
Doctor.
Doctor.
Thank you, Doctor.